Hello, everyone. I'm an associate professor at the Spanish university. So, first of all, innovation is not my core business. Actually, I'm more into research. So my objective, at least before this project, was just publishing papers. But this was my first serious attempt at innovation. It was a European innovation project funded by Horizon 2020. The motivation for this project actually was the combination of us researchers looking for an appropriate platform to develop vision-based products, and a company at the time, Movidius, looking for uses for their latest platform. So that was the key combination that led to this project. And there were some, well, it's a medium-sized project, but some well-known names of like Movidius, which was, as you know, acquired by Intel, and also Thales, some other partners. This was the idea, and the result. We built a hardware and software platform for embedded computer vision. It was based on the Myriad 2 chip, or SoC, by Movidius, which has been, as you know, used in many other products from big clients, I would say. So it was for computer vision. It included, let's say, classical vision methods, but also deep learning. Only the inference, of course. So we did some tests, and you will see some demos later, in which all of this is done using low power consumption. So we also used techniques for low power consumption, both at the hardware level and also at the software level. The board itself contains the Movidius chip as the core element, but it also contains a wireless Wi-Fi chip, low power Wi-Fi chip, low power cameras, and USB connection, power connectors, etc. So everything is can be operated with a flat battery. The bill of materials at the end was around 120 euros. That's of course just the bill of materials, just that. One of our objectives while working throughout this project was to make it open in the sense that to make it very easy to use for everyone. That was our objective at the start of the project, but it turned out that this was impossible, actually, because in the end, all of these technologies were very difficult to use, even for us engineers, seasoned engineers. So we wanted to have a Python there, something very easy to use, but our initial idea had to be changed, because indeed this device was very, very powerful, but it wasn't easy to use at all. But we used that to our advantage, as we'll see in a moment. These are some of the demonstrators that we developed with the platform. Of course, as you can see in the first picture, you can use it in robots, different types of robots, mobile robots, and I think you may have seen either today or tomorrow, you may see more examples of this. Drones, you can think of drones, of course. In the top right image, this is one of the demonstrators in which the device is in a headset configuration, and when you arrive, the idea is when you arrive at the museum as a visitor, you take one of those headsets, you put it on, you turn it on, and the camera is constantly looking at the painting you're looking at. It recognizes the painting without your doing anything, so everything automatic. And once the painting is recognized, it can provide you with audio feedback about the painting. So it's a museum guide, but completely hands-free. And actually, we did some measurements about power consumption, and you can use this for a full day, so that's good. At the bottom, you can see that we also inserted this device into a doll and put the camera in the doll's head. And here, the software part, we developed the software to use a small deep network to do facial analysis, to recognize the child's facial expressions. Okay, so as I said, actually the project went well. We did the review in Brussels, and we got the highest mark, so it was, at least up to this point, it was a success. In parallel, an Irish startup, Yotaka Technologies, was incorporated in late 2016. That's roughly midway into the Eyes of Things project. They were, from the beginning, they were very interested in our technology. They had contacts with people from Movidius, so they were like looking at us and very interested in what we were doing. And so they managed, in the end, as I said, what we wanted is to make something very easy to use, but we discovered that was not possible. But what we gained through the project was actually our know-how of how to deal with those technologies, how to work with the Myriad chip in the first place, and how to develop software for that. That was the major value that we got inside the project. So this company actually ended up recruiting people from EOT, from the EOT project. Actually, the hardware chief designer was recruited by Yotaka as lead engineer. The project coordinator was also kind of recruited as technical advisor. They are headquartered, as I said, in Dublin, Ireland, but they have also set up a branch in Spain, late 2018, and where they have also recruited the main software developers in Eyes of Things. That's the current status, more or less. As for this company, you will hear more about the company tomorrow, because they are also participating in the Edge AI session tomorrow. That's the last session tomorrow. So I hereby invite you to attend that session. These are two of their flagship projects at the moment. What they call Smart Warehouse with Intel and Lenovo, and the Earth observation projects that they are having with the European Space Agency. The first one is for large warehouses. Actually, they have one, they're using one Lenovo warehouse in South Carolina in the US. The fancy name is Video Orchestrated Inventory Management, but the whole idea is to use overhead cameras to identify forklifts moving in the warehouse and pallet IDs, and always using technology like the one we used in EOT, so everything Myriad-based, with the Myriad 2 and the latest Myriad X chips. In different form factors, like the USB stick, you may already know it, the neural compute stick, and PCI form factors. There are different options here. This is a snapshot of one of the software. The codes are similar to QR codes. These are actually called data matrix, which are supposed to be more robust. And the cameras around the warehouse can recognize and track both the forklifts and the pallet IDs. That's the main idea. As for the projects for the ESA, this is at an initial stage where they are basically characterizing the boards, the EOT board and the Myriad chip, for conditions in space. So they have been basically throughout initial stages where they bombard the board with, I don't know, rays of protons or whatever, just to know how the hardware behaves in terms of errors and things like that. So that's the initial stage. But the idea is to send one of these boards to space in a small cube satellite that I understand will fly to space in July this year. So again, you may hear more details in tomorrow's session. So, as I said, this was my first serious attempt at innovation, but it turned out very well, actually. So I'm very happy about that. Thank you very much.